All right. A couple of application questions for Vertex form problems. An object is launched from a platform. Its height in meters, x seconds after launch, is modeled by this expression. H of x equals -5 times x minus 4 squared plus 180. This is function notation. The height of the object depends on how long it's been in the air, how long after I threw it. The height of the object is modeled by x, modeled by how long it's been in the air. That's equal to -5 times x minus 4 squared plus 180. If I kind of picture what's going to go on here, let me draw a quick graph. Along the x-axis, x represents time in seconds. Based off of how many seconds the object's been in the air, we would know the height of the object in meters off the ground. When I throw something up into the air, what happens? Do that one more time there, Ava. What shape is she kind of doing there?
Upside down here.
A parabola, right? A parabola that's concave down, in other words. So we're going to launch it from here. It's going to start to go up, obviously, because I've thrown it upwards, and then gravity takes over. Eventually, I'm going back down. From the platform, I throw the object up into the air. It starts to go up and then comes back down. I took a minute this morning and graphed this up on Desmos. The same basic shape for our specific function that I've graphed here. From the platform, throw it up into the air, and it comes back down. The x-axis measures time in seconds. Our vertical y-axis represents the height of the object. You see what's going on here so far? Okay, let's ask a few questions here. How high is the platform? How long after launch is the maximum height of the object? And when does it reach the ground? I think these questions are best understood by thinking about what is it really asking me to find? What point on the parabola is that referring to? So how high is the platform? Where on the graph would that be located here? Y-intercept. The y-intercept. How long has the object been in the air if it's on the platform? What does x have to be on the y-axis, in other words? 0, because it hasn't left yet. It hasn't been shot into the air. Katie said, shouldn't x be 0 because I haven't thrown the rock yet? Time is still 0 because it's on the platform. We're going to find h of 0. We're going to plug 0 in for x to find the y-intercept. What is the height of the object for when time is 0? It hasn't left the platform yet. I haven't released it. So time is 0. What's the initial height? -5 times 0 minus 4 squared plus 180. Start simplifying. What do we do first, Chris? What our operation says to start where? Think PEMDAS. No, we're just simplifying. We're not trying to solve the equation. I just want to know what this is equal to. So order of operations, PEMDAS says to begin by doing what? What does the P stand for? How about parentheses? Do what's inside the parentheses first. What's 0 minus 4? Okay, so I'm going to bring down -5 times -4 squared plus 180. Do exponents next. Kennedy, what's -4 squared? -4 times -4. -4 twice.
Be -2 and 2.
Oh, so we're taking square roots. I want to square 16. -4 times -4 is positive 16. Okay, so I'm down to here so far. I plug in 0 to find how high the platform was. When time is 0, how high was the object launched? I've got 16 times -5 plus 180. Might need a little help. What is -5 times 16? I don't know.
-80.
-80, but okay. Negative
I was
80
thinking 16 times 5.
plus 180.
Yeah,
100.
100.
The platform that I threw the object off of is 100 meters in the air. And I can see that by clicking on that dot here on the television screen. When x is 0, before I launch the object, it's located on a platform 100 meters in the air. Our y-intercept, in other words, when x is 0, is 100. Part 2. How long after launch is the maximum height? The maximum point, the highest point on the parabola. What's that referred to as? Vertex. Put in other words, isn't this just asking you to find the vertex?
Yeah.
Put another way, just means find the vertex. Since this is in vertex form, that's not hard. Okay, then what is the vertex? Look at your equation here, or up on the board. What's the vertex? Make x minus 4 into 0.
In vertex form.
It is in vertex form, yeah.
I mean, positive 4, positive 180.
Good stuff.
Which one of those numbers is the height? There's two numbers. He said two numbers. Which one's the maximum height of the object? 180. Its maximum height of 180 is after 4 seconds from launch. It takes 4 seconds after I threw it for the object to be at its highest point, 180 meters off the surface. 4 seconds later, the maximum height of the object is 180 meters because that's the vertex. That's the highest point on our parabola. Decimals should say the same thing right there. Lastly, when does the object reach the ground? Where would that be located at on my graph? X-intercept. Put another way, this means find the x-intercepts. Tori, what's the height of the object when it lands on the ground? What should the height be when it's on the ground? 0, right? So what x value makes the height into 0? What x value turns the whole thing into 0? Let's set our function h of x equal to 0 and see what x value makes the height equal to 0. So I want to know what x value, how many seconds does it take for the height to become 0 and the object to hit the ground? 4. No, at 4, it's at its highest point. That's the vertex.
Takes 4 seconds to go back down.
No. Because it's not the full parabola. I have more to the right than I would to the left. Caleb, what can I do to start solving though?
It'd be 9.
Close. Get x by itself, Caleb. What's the first number I have to subtract away?
You have to subtract 4 and 5.
Nope. What do I take away first? How do I get started? Say it, Sophie. 180. Subtract 180 from either side. So negative 180 equals negative 5 times quantity x minus 4 squared. Before I take square roots, I got to know what's being squared. There's still a negative 5 out in front. What's the opposite of multiplying by negative 5 to start simplifying? Divide by negative 5. Cole, do you want to get that for me? What's 180 divided by 5? I don't know. Good. So I reduce this down to 36 on the left, equal to the 5's cancel out. Just x minus 4 quantity squared on the right. We've solved stuff like this before this week. What's the opposite of squaring something? What can I do to get rid of the second power from both sides? Square roots. I think that's what Kennedy was confused with last time. I square root the left and the right. When I square a square root, it cancels out. What's the square root of 36?
6.
6 is half the answer. What's the other?
6 and positive 6.
Negative and positive 6. The square root should tell you what number times itself makes 36. 6 times 6 is 36, so is negative 6 times itself. I want to get both answers, so let's make sure I write both of those down. Plus or minus 6 equals x minus 4. Still haven't solved for x yet, because I'm still subtracting 4 from it. Add 4 to both sides. So x equals both plus or minus 6 plus 4. There's really two answers here because plus or minus 6 is two different numbers. Either 6 plus 4 or the negative part, negative 6 plus 4.
10 and negative
6 plus 4 is 10. Or negative 2. Negative 6 plus 4 or negative 2. Which one's the answer? Does it take 10 seconds for the rock to hit the ground or negative 2 seconds?
2.
Why not negative 2?
Because we're going forward.
Yeah, time can't be negative. Time travel is not really going to be a thing so far. If I look back on the television screen, if I pull up the graph on Desmos, I think at 10 seconds, the height becomes 0 and the rock hits the ground. After 10 seconds, the rock's back down on the surface.